This is Electronics with Mr. Estabrooks, and today we're going to take a look at series circuits and circuit theory as it applies to series circuits. And we're going to look at an example series circuit. Remember, one electrical pathway. We're going to analyze this circuit and calculate total resistance, total current, and the voltage drop across each of the three resistors. So the first thing you'll remember is, from the last video, the total resistance in a series circuit is simply the sum of the individual resistors in the circuit. Whoops. So R1 plus R2 plus R3 is 110 ohms plus 330 ohms plus 560 ohms. If you add that up, it works out to be 1,000 ohms, or 1 kilo ohm. Now, once we have the total resistance, we know the total supply voltage, we can then calculate total current using Ohm's law, because, as you should recall, I equals V divided by R. So if we substitute the values, we have 12 volts divided by 1,000 ohms. Remember, we're calculating total current, so we use total voltage, and I could put a little t there if I wanted to be a little bit more descriptive. And total resistance. 12 volts divided by 1,000 ohms is 0.012 amps, or 12 milliamps. So our final answer for total current is 12 milliamps. Now, here's the new part. How do we calculate voltage drop across a resistor? Well, there's actually two ways to do it. If you can get the total current, which we have, and you'll remember that current in a series circuit is the same everywhere, then you can use Ohm's law, isolate each resistor, and you know that VR1 equals IR1, that is the current going through the resistor, times R1, which equals 12 milliamps, or 0.012 amps, times 110 ohms. And I believe that works out to 1.32 volts. So that's one method. The other method is what I call the proportional method. And there are different times to use different methods, but it's always good to have two ways of doing something, because then you could use one method to calculate it and the other method to check your answer and make sure you got the right answer. The proportional method basically states that the voltage drop across a resistor is equal to the ratio, or the proportion, of the resistor divided by the total resistance multiplied times the total voltage. So R1 over RT is the ratio of the R1 resistance divided by the total resistance, which we calculated up here. And you multiply that ratio, or that proportion, by the total voltage, 12 volts. So if you multiply that out, we get 100 for R1, 110 ohms divided by 1,000 ohms times 12 volts gives us 0.11 times 12. Lo and behold, equals 1.32 volts. So we just used two different methods to calculate the voltage drop across R1, and we got the same answer. If you do that in class or on a homework or on a test or quiz, that should give you a pretty good assurance that you got the right answer. Now let's try it for VR2. I'll use the proportional method. And this is actually pretty easy. If you look at it carefully, you'll see that R2 is just 3 times R1. So really, if the resistance is 3 times R1, the voltage drop is going to be 3 times R1 because it's just proportional. But we'll just do the math just to make sure. 330 ohms over 1,000 ohms times 12 volts equals 0.33 times 12 equals 3.96 volts. Don't forget the units, right? So, last one, VR3 equals R3 over RT times VT equals 560 ohms over 1,000 ohms times 12 volts equals 0.56 times 12 equals 6.72 volts. Now, here's where you can do even another double check. Remember, Kirchhoff's voltage law states that the voltage drop across all 3 resistors, if you add them up, it equals the source or the total voltage, the supply voltage. Well, we got 1.32 plus 3.96 plus 6.72. Add those up. What do you get? Well, you better get 12 volts. If not, you did something wrong. If this doesn't work out, then I did something wrong.